Hi friends, welcome to our channel. Today's topic is Srinivasa Ramanujan's contribution towards the world of mathematics. At an early age of 12, he invented his own method of solving quadratic equations. Here is an expression of a general quadratic equation. He also gave unforgettable contribution in analysis, game theory, and infinite series. Here is an expression. Elementary mathematics such as algebra, Ramanujan enjoyed finding sum of powers 1729 is the number he discovered and expressed as the sum of two cubes. Here is the expression. Identity is given by Ramanujan if a plus b plus c equals to 0. Ramanujan discovered the theta function and modular function that have application to number theory. This is the expression. He worked on partitions, sum of squares, triangular number and Ramanujan's tau function. Here is the expression of the same. He discovered the formula for infinite series of pi. Here is the expression. Ramanujan was well known for his asymptotic formula in number theory. Here is the formula along with his picture with G.H. Hardy. He gave 2000 contribution to continued fractions. This is the expression. No one in the history of mathematics had skill of finding continued fraction of various functions. He developed exceptionally efficient way of calculating pi that were later included in computer algorithms, various formula in physics to describe the motion of pendulum and vibration of string, also the alternating current. Ramanujan's number theory has best application in cryptography as well. Cryptography is very much used in computer programming. Ramanujan independently compiled nearly 3900 results during his short lifespan. Approximately all claims have now been proven correct. He investigated series and calculated Euler's constant to 15 decimal places. Here is the expression of the same. He also worked on Bernoulli's number. In the end, we can conclude that no one can express Ramanujan's work in just words. Friends, if you like our presentation, do.
Hello friends, in this video I shall be taking up a very interesting concept. This concept is a 4 by 4 magic square. Now you all know what is a magic square, right? We write some numbers in a particular matrix like this, and the sum of those numbers in each row, in each column is same. That's known as a magic square. This concept of magic square finds a place in junior class curriculum, but there we have very basic magic squares. Now what we are going to do here is to create magic squares from the date of birth. Yes, even you can create a magic square from your date of birth. You want to know how? Just watch this video till the end. I'm sure you are going to learn a lot of things from this particular video. So for taking an example, I'll write 16 numbers in this matrix, 4 by 4 matrix, and then explain what is so special about this magic square. The first row has 22 in the first cell, 12 in the second, then 18 in the third, and 87 in the fourth. The second row has 88, 17, 9, and then a 25. Then in the third row we have 10, 24, 89, 16, 19, 86, 23, and 11. Now the special thing about this magic square, 3 or 4 obvious things are there that I'll write first. Sum of all numbers in a row. So 22, 32, 34, 44, 52, 52 and 89 is 139. So every row the sum will be same, 139. So that's very basic, right? Nothing new in that. Sum of all numbers in a column, that's again very normal, 22, 110, 120, 139. So again 139. So every column has sum 139. So 4 plus 4, 8 times the sum is 139. Now come to the sum of the numbers along the diagonals. Again, this is also known to you. 22, 39, okay, 128 and 11, 139. So again 139. You can check this diagonal also. This will also be 139. Now the special thing about this particular 4 by 4 magic square. Actual thing starts from here. So keep watching. If you have a 4 by 4 matrix which I have drawn like this, so I am drawing yet another just to represent which 4 numbers will have the sum as 139. Okay. Apart from these 3, the first one is just check the 4 corners. So corners 22, 109, 128 and 139. So again corners has the sum 139, the 4 corners. Then come to, I'll just remove this. Take these 4 numbers along the opposite edges, the center numbers. 12 and 18 is 30. So this is 116 and 23, again 139. Take these 4 numbers, 88, 98, 108, 114, 139, again 139. You want more? The fun is not over. Just keep watching. Okay. You have seen these 4 and these 4 now. Now come to symmetrical like this. 1, 2, 3, 4. Check these 4. This is 100. 16 and 23 is 39. So 139 again. Likewise, you can check symmetry like this. 18 and 25 is 43. 53 and 86 is again 139. Yet another important thing. Then check the 4 numbers in the center. 89, 98, 108, 115 and 24. 139 again. Still not over. There are some more patterns. You can see I'm drawing it again. You will be surprised how many times 139 exists in this magic square. Check the 4 numbers like a Sudoku. Here we have these 4 numbers. 110 and 29 is 139. check these 4, again 139, check these 4, again 139, and now check these 4, again 139. So many different patterns, and as if this is over now, right? No, there are 2 more patterns which you can locate in this particular magic square. We have taken squares like this, right? So take squares like this and like this, just try with them. Again you are going to find the sum of those numbers as 139 only. Very interesting. And apart from the traditional rules of the magic square, these 3, so many different patterns are there in which that sum of 139 is obtained. You know why this is more important? Because this was propounded by the mathematics genius Srinivas Ramanujan. And why I call this trick as magic square from date of birth? This particular row, the first row which I have written here, so that particular row is actually 22nd December 1887. So 22nd December 1887. This is actually the date of birth of the great Srinivas Ramanujan. And when he propounded this magic square and told us about so many different patterns which exist in this magic square, he told us the reason also, and he gave us the trick to make your own magic square. Okay, so now let's try and take our own date of birth and try to find a magic square which satisfies all these conditions which are satisfied by the magic square written here. So I'll just tell you the method through which you can draw your own magic square, and you can try with your own date of birth. I'm sure you are going to get an amazing result, and you can amaze your friends by showing them this particular trick. What you have to do is you have to write your date of birth like 22nd, month of birth, so 12 December. If you have a month like July, so it will be 07. Then the century year, like he has 18, so century, and the year. So DD, MM, CC, YY. This is the format in which you have to write your 4 double digits, and they have to be double digits. If they are single digits, you have to prefix a 0, and that can happen in the date and the month. Now, how do we write the other numbers? You know, when we have the date here, then date plus 3, whatever is the date plus 3, that number should come here. See, 22 plus 3 is 25. Date plus 2 should come here. You can see 22 plus 2, 24. And date plus 1 will come here. So plus 1 plus 2 plus 3, 22, 23. That will give you the next 3 numbers. Now come to the month. Month minus 3 will come here. So you can see 12 minus 3 is 9. Month minus 2 will come here. You can see 22, okay, 12 minus 2 is 10. And finally, month minus 1 will come here. You can see 12 minus 1 is 11. Likewise, taking into consideration the century year, 1 less than that will come here, C minus 1. 2 less than that will come here. You can verify from here, 18 minus 1 is 17, 18 minus 2 is 16. And 18 plus 1 is 19, so C plus 1 comes here. And finally the year minus C to 87, 88, so year plus 1, right? Then this column 89. So 87 becomes 89. So year plus 2. And finally 87 becomes 86 here. So year minus 1. This is the amazing rule through which you can all make a magic square from your own date of birth. I tried making one and I succeeded. For example, I went with my date of birth, which is 18 July 1973. So 18 July is 07, or you can write 7, no issues. 1973. Okay, now date plus 3, 21, date plus 2, 20, date plus 1, 19. Month minus 3, so month is 7, right? So minus 3 is 4, month minus 2, so 7 minus 2 is 5, and month minus 1, 7 minus 1 is 6. Now come to the century year, C minus 1, so 19 minus 1 is 18, which comes here. C minus 2, so 19 minus 2 is 17, and C plus 1, so 19 plus 1 is 20. And finally the year, 73 plus 1 is 74, which comes here, plus 2 is 75, which comes here, and minus 1 is 72, which comes here. Now if you watch carefully, all these patterns which I have told you here, they will be followed in this particular magic square. Whether you take the corners or the diagonals or the rows or the columns or the boxes like this, or the symmetrical portions like this or like this, boxes here, everywhere the sum will be same. So you can verify what is the sum here. This is 75, 80, 100, 117. So in this case, from my date of birth, I am getting a sum of 117 along all sides which I have mentioned just now. This is something very, very unusual and very, very interesting, propounded by the great Srinivas Ramanujan. So friends, these are the videos we need to follow to develop that particular kind of mathematical aptitude we should have towards maths, and these do help you in creating interest among the junior students. Especially for the teachers, they should follow all these videos and use them in the classroom to develop mathematical aptitude in junior students so that they don't struggle with mathematics at higher level. So friends, if you like this video of magic squares from date of birth, do try this with your date of birth and see what is the sum of all the numbers you are getting along all these directions. And don't forget to share it with your friends so that they can also amaze their own friends and surprise them with such nice tricks. So friends, thanks for watching this, and I hope you are sharing all the videos of this channel. Let's spread Vedic maths in the world. And of course, if you subscribe the channel, you have to click the bell icon also to get the notifications of all future uploads. Thanks for watching this, friends.
वैसे तो श्रीनिवास रामानुजन ने ऐसी कई डिस्कवरीज की है जिसने कि पूरी दुनिया को हिलाकर रख दिया, लेकिन आज हम एक ऐसी इंटरेस्टिंग चीज के बारे में पढ़ने वाले हैं जो कि श्रीनिवास रामानुजन से ही रिलेटेड है। आज हम पढ़ने वाले हैं रामानुजन मैजिक स्क्वायर के बारे में। आखिर रामानुजन मैजिक स्क्वायर किसको कहते हैं? तो सबसे पहले ये है हमारा स्क्वायर और ये है इसके एलिमेंट्स। इसको हम कहते हैं रामानुजन मैजिक स्क्वायर। आखिर इस स्क्वायर में ऐसी क्या खास बात है? सबसे पहले तो अगर आप इस स्क्वायर के पहली, दूसरी, तीसरी और चौथी रो के एलिमेंट्स को प्लस करेंगे तो हर रो का आंसर आपका 139 आएगा। अब अगर आप रो को हटाकर कॉलम्स को प्लस कर देंगे तो आपका कॉलम्स का भी सम 139 आएगा। अब अगर आप इस स्क्वायर के डायगोनल के एलिमेंट्स को प्लस करेंगे तो भी आपका आंसर 139 आएगा। दोनों डायगोनल्स की बात कर रहा हूं मैं। और अगर आप इस स्क्वायर के कॉर्नर के एलिमेंट्स को प्लस करें, जैसा कि आप देख पा रहे हैं, तो भी आपका आंसर 139 आएगा। अगर आप ये चारों एलिमेंट्स, जैसा कि आप देख पा रहे हैं, या फिर ये चारों एलिमेंट्स को प्लस करेंगे तो भी आपका आंसर 139 आएगा। और आखिर में अगर आप इस स्क्वायर के बीच के चारों एलिमेंट्स को प्लस करेंगे तो भी आपका आंसर 139 ही आएगा। तो इसका मतलब क्या मैं ये मान लूं कि 139 एक स्पेशल नंबर है? जी नहीं, 139 कोई भी स्पेशल नंबर नहीं है, ना ही इस स्क्वायर को बनाना कोई कठिन काम है। आप भी ऐसा स्क्वायर तैयार कर सकते हैं। सबसे इंटरेस्टिंग चीज इसमें देखने की ये है कि अगर आप इस स्क्वायर के पहले रो के एलिमेंट्स को देखेंगे तो आपको मिलेगा 22, 12, 18 और 87। एक्चुअली ये श्रीनिवास रामानुजन की डेट ऑफ बर्थ है। जी हाँ दोस्तों, 22 दिसंबर 1887 को ही श्रीनिवास रामानुजन का जन्म हुआ था। तो इसका मतलब ये डेट ऑफ बर्थ से रिलेटेड है। अगर आप श्रीनिवास रामानुजन की डेट ऑफ बर्थ को कुछ इस तरीके से प्लस करेंगे तो आपका आंसर 139 आएगा। इसका मतलब मैं किसी भी डेट ऑफ बर्थ का इस्तेमाल करके ऐसा मैजिकल स्क्वायर तैयार कर सकता हूँ। मैं आपको एक एग्जाम्पल करके दिखाता हूँ। अगर मैं एक डेट ऑफ बर्थ मान लूँ 30 अगस्त 2005 और मैं यहाँ पर ए को मान लेता हूँ 30, बी को मान लेता हूँ 08, सी को मान लेता हूँ 20 और डी को मान लेता हूँ 05, बचा हुआ हिस्सा। अब मैं स्क्वायर के पहले रो में लिख दूंगा ABCD कुछ इस तरीके से। अब उसकी दूसरी रो में मैं लिखूंगा D+1, यानी D वाले एलिमेंट्स में +1 कर दूंगा, और तीसरी वाली में लिखूंगा मैं C-2 और चौथी वाली में मैं लिखूंगा B+1। तो इस तरीके से अगर आप देखेंगे, अगर मैं पहली कॉलम को प्लस करूं तो आप देख रहे होंगे +1, -2 और +1 ये सब मिलाकर 0 बन जाएंगे और मेरी पहली कॉलम का आंसर आ जाएगा A + B + C + D। तो कुछ इसी तरह मैं बाकी सारे एलिमेंट्स को भी फिल करूंगा। ये आपकी वैल्यू है। आप जब इस तरीके से वैल्यू को पुट करेंगे ABCD की तो कुछ इस तरीका का स्क्वायर आपको देखने को मिलेगा, और आप वही सारी प्रॉपर्टी इस स्क्वायर में लगाकर देखिए, रो वाली, कॉलम वाली, डायगोनल वाली, और आपको इस बार सम मिलेगा 63, क्योंकि मेरी डेट ऑफ बर्थ का जो सम है वो 63 आ रहा है। तो आप इस तरीके से कोई भी मैजिक स्क्वायर तैयार कर सकते हैं और किसी को भी दिखा सकते हैं। अगर आपको मेरा ये वीडियो पसंद आया है तो मेरे चैनल को सब्सक्राइब कीजिए, इस वीडियो को लाइक कीजिए। थैंक्स फॉर वॉचिंग।
Srinivasa Ramanujan was born on 22nd December 1887 in Erode, India, a small village in the southern part of the country. Shortly after this birth, his family moved to Kumbakonam, where his father worked as a clerk in a clothes shop. Ramanujan was a child prodigy and a mathematical genius. The greatest thing about him, probably, is how he turned out to be this amazing mathematician, despite having little or no formal outside exposure to advanced mathematics. He was a self-taught genius from a very humble origins, completely disconnected from the world of other excelling mathematicians, and largely worked out of his own, in utter isolation, and often in poverty. Ramanujan possessed an incredibly amazing intuition of numbers, fractions, and infinite series, possibly like no other mathematician ever did. He churned out a huge number of significant and complex results, largely based on intuition mingled with argument and induction, and some sort of innate insight that only seemed to be possessed, often without formal proofs and coherent accounts. Ramanujan attended the local grammar school and high school and early on demonstrated an affinity for mathematics. When at age 15, he obtained an out-of-date book called A Synopsis of Elementary Results in Pure and Applied Mathematics. Ramanujan set about feverishly and obsessively studying its thousands of theorems before moving on to formulate many of his own. At the end of high school, the strength of his schoolwork was such that he obtained a scholarship to the government college in Kumbakonam. But Ramanujan's greatest asset proved also to be his Achilles heel. He lost his scholarship to both the government college and later at the University of Madras, because his devotion to math caused him to let his other courses fall by wayside, with a little in a way of prospects. In 1999, he sought government unemployment benefits. Yet, despite these setbacks, Ramanujan continued to make strides in his mathematical work, and in 1911 published a 17-page paper on Bernoulli numbers in the Journal of Indian Mathematical Society. Seeking the help of members of the society, in 1912, Ramanujan was able to secure a low-level post as a shipping clerk with the Madras Port Trust, where he was able to make a living while building a reputation for himself as a gifted mathematician. Around this time, Ramanujan had become aware of the work of British mathematician G. H. Hardy, who himself had been something of a young genius, with whom he began a correspondence in 1913 and shared some of his work. After initially thinking his letters a hoax, Hardy became convinced of Ramanujan's brilliance and was able to secure him both a research scholarship at University of Madras as well as a grant from Cambridge. The following year, Hardy convinced Ramanujan to come study with him at Cambridge. During their subsequent 5-year mentorship, Hardy provided the formal framework in which Ramanujan's innate grasp of numbers could thrive, with Ramanujan publishing upwards of 20 papers on his own and more in collaboration with Hardy. Ramanujan was awarded a Bachelor of Sciences for Research from Cambridge in 1916 and in 1918 became a member of the Royal Society of London. Ramanujan made many momentous contributions to mathematics, especially number theory. Much of his work was done jointly with his benefactor and mentor G. H. Hardy. Together, they began the powerful circle method. The circle method has played a major role in subsequent developments in analytic number theory. Ramanujan also discovered and proved that 5 always divides p bracket 5n plus 4. 7 always divides p bracket 7 9 plus 5. And 11 always divides p bracket 11 9 plus 6. This discovery led to extensive advances in the theorem of modular forms. Of Ramanujan's published papers, 37 in total, Professor Bruce C. Burnt reveals that a huge portion of his work was left behind in 3 notebooks and a lost notebook. These notebooks contain approximately 4,000 claims. Most of these claims have now been proved, and like his published work, continue to inspire modern-day mathematics. A biography of Ramanujan titled The Man Who Knew Infinity was published in 1991, and a movie of the same name starring Dev Patel as a Ramanujan and Jeremy Irons as Hardy premiered in September 2015 at the Toronto Film Festival. Years of hard work, a growing sense of isolation, and exposure to the cold, wet English climate soon took their toll on Ramanujan, and in 1917 he contracted tuberculosis. After a brief period of recovery, his health worsened, and in 1990 he returned to India. Srinivasa Ramanujan died of his illness on 26th April 1920 at the age of 32, and even on his deathbed had been consumed by math, writing down a group of theorems that he said had come to him in a dream. These and many of his earlier theorems are so complex that the full scope of Ramanujan's legacy has yet to be completely revealed, and his work remains the focus of much mathematical research. His collected papers were published by Cambridge University Press in 1927. Thank you for watching Edupedia World. Please subscribe to watch more videos.